Today, we are tackling a problem that pretty much defines the modern internet. How in the world do you store a mountain of data? We're going to trace the whole evolution, from Google's very first clever solutions all the way to the massive cloud systems we use every single day. All right, let's dive in.
So it all starts with this one simple but absolutely massive problem. What happens when your data isn't just measured in gigabytes anymore, but in terabytes or even petabytes? Your good old traditional database, it just breaks. This explosion of data created a whole new set of challenges that, frankly, required a completely new way of thinking.
And that first challenge, the one that really sparked this whole revolution in data storage, was simply the sheer volume of it all. People started calling it the data deluge.
Okay, so the core challenge really boiled down to a few key problems. First off, the files were just gigantic. Second, trying to move terabytes of data across a network was incredibly slow and super expensive. And third, and this is a big one, when you build a system with thousands of cheap, off-the-shelf computers, you have to just accept that some of them are going to fail. All the time. So the real question became, how do you store and process all this data reliably and efficiently when everything is stacked against you? Well, the first real breakthrough came from a company that was facing this problem at a scale that was just unimaginable at the time, Google, which back then was still a scrappy startup just trying to organize the entire internet. This is their blueprint. You know, it's funny how these things start. A secret internal project at Google ended up becoming the foundation for an entire industry. It began with a system called Big File, which led to this groundbreaking research paper in 2003 on what they called the Google File System. And that paper, it was a total light bulb moment for the open source community, which then went on to create Hadoop and HDFS, the technologies that really powered that first wave of big data.
So what is HDFS really? The best way to think about it is like a magic filing cabinet. You give it a document that's, say, 1 million pages long, and it automatically rips it into smaller chunks, makes a few copies for safety, and just scatters them across thousands of different drawers. And the crucial part is it remembers where every single piece is, so you don't have to. Okay, so let's peek inside and see how this magic cabinet actually works. You've got a master librarian, and it's called the name node. Now, it doesn't hold any of the data itself, but it keeps this incredibly precise catalog of which data blocks are on which worker machine. The workers? Those are the data nodes. They're the ones that actually store the pieces of your files. So when you need a file, you just ask the name node, and it tells you exactly which data nodes to go talk to. And this right here is the genius of the system. This is how it handles all those hardware failures we talked about. See how the different colored blocks, which represent parts of a single file, are copied onto multiple machines? HDFS makes multiple replicas of every single data block, usually 3. So if one of those data node machines suddenly fails, just goes offline, it's not a problem. The name node knows exactly where the other copies are, and your data stays completely safe. That's fault tolerance built right into the very core of the design. All right, let's move on to the next evolution. See, just storing data was one thing, but businesses needed to actually make sense of it. They needed a way to analyze curated, clean information to make critical decisions. This need led to the rise of the data warehouse. The data warehouse is a fundamentally different concept. If HDFS is a giant, kind of messy workshop, a data warehouse is more like a pristine, perfectly organized museum archive. It's not for storing everything. It's for storing really important, cleaned and structured information that business analysts can easily query to get reports and insights.
The heart and soul of the warehouse is a process called ETL, extract, transform, and load. This is the rigorous cleaning process. First, you extract raw data from all over the company. Then you transform it by cleaning up errors, getting rid of duplicates, and putting it all into a standard format. And finally, you load that high-quality, trustworthy data into the warehouse where it's ready for analysis.
And you can see that whole flow right here. Data comes in from all these different sources, it goes through that super critical ETL process, and then it lands in a central data warehouse. From there, business intelligence tools can connect to it to create all the reports and dashboards that help leaders make those big informed decisions. But then, a new need started to emerge. With the rise of machine learning and AI, data scientists realized they didn't want the perfectly clean, transformed data. No, they needed the raw, messy, unfiltered stuff, because that's where all the hidden patterns and valuable signals could be found.
The warehouse, by its very design, was throwing all of that good stuff away. And so the data lake was born. A data lake is pretty much the philosophical opposite of a warehouse. It's a massive repository where you just dump everything: structured tables, unstructured text, images, server logs, you name it, all in its original raw format. Think of it like a huge depot of raw materials. You might not know what you're going to build with it yet, but you have everything you could possibly need right there at your fingertips. Okay, this comparison table really nails the difference. But the biggest thing, the one you really got to remember, is the schema. A warehouse uses something called schema on write, which means you have to structure the data before you can store it. A lake uses schema on read, where you store it raw and then apply a structure later, when you're actually analyzing it. This is what makes warehouses so perfect for business reporting, and why lakes are ideal for the messy, exploratory work of data scientists. This brings us right up to the modern era, which is, of course, completely dominated by the cloud. And cloud computing required a brand new kind of storage, something incredibly simple, infinitely scalable, and really, really cheap. Enter object storage. Object storage just throws out that whole complex idea of folders inside of folders that we're used to. Instead, you have one single, giant, flat space where you store objects. An object is just the data itself, like a photo or a song, plus a unique ID to find it, and some metadata describing what it is. It's a beautifully simple and incredibly powerful idea. And the crazy thing is, you use it all day, every day. The photos on social media, the music you stream, the files in your cloud drive, all of that is powered by these massive object storage systems like Amazon S3 or Google Cloud Storage. Its popularity with developers really comes down to its dead simple design. The process has 3 basic steps. 1. You create a container called a bucket. 2. You upload your file or object into that bucket and give it a unique name or a key. And 3. When you need it back, you just ask for it using the bucket and key. That's it. It's that simple. So after this whole journey through HDFS, warehouses, lakes, and object storage, how do all these pieces actually fit together in the modern data toolkit? Okay, and here's the most important takeaway of all. These technologies didn't really replace each other, they formed a modern toolkit. A company today might use a data lake built on top of object storage to hold all of its raw data, then use an ETL process to move a clean little subset into a data warehouse for its business analysts. They're just different tools for different jobs. So to summarize, here's your big data cheat sheet. Think of it like this. HDFS is for when you got massive files on your own cheap servers. A data warehouse is for clean, structured analysis. A data lake is for all that raw, messy data you need for AI. And object storage? That's the simple, scalable backbone of the entire cloud. We've come a really long way from simple databases, but that data deluge we talked about, it is only accelerating. Which leaves us with a final question. As data continues to grow in scale and in complexity, what will the next generation of storage tools even look like? What new challenges are waiting just over the horizon?